Hello, dear children. Welcome to mathematics class for class 6. Today we'll be continuing with chapter 11, Algebra. Now we have already finished the conceptual part. We will move on to exercises, okay? So we will try to solve as many problems as possible. The first exercise will be exercise 11.1. It is on page number 226 of your textbook. So let's look at the first question. So the first question reads as, find the rule which gives the number of matchsticks required to make the following matchsticks pattern. Use a variable to write the rule. Now we have already learned about the matchstick pattern. See here, a pattern of letter T as, it's given in this manner. Let's say that these are your matchsticks, okay? These are your matchsticks. Now you can see 1, 2, 2 matchsticks, right? So it is the same as the examples that we did for writing L. Here we have 1, 2, 3, 4, 5, 6. 6 matchsticks, and how many L's here? 3, right? So when we draw 3 matchsticks, we're getting when we draw 3 L's, we are using 6 matchsticks. That means for 3 to reach 6, we multiply with 2, right? So in the same way, we represented we represented 2 as constant and 3 as n, right? So similarly for this also, we will use the pattern 2n. That means this n is number of T you are making. If you make, let's say these are your matchsticks. If you make 2 T's, so 2 into, in place of n, I will put 2. So you will get 4. That means you are using 4 matchsticks. Let's count 1, 2, 3, 4. All right. So this is the same as the example that we did in the concept classes that we took. Please do not be confused. So similarly for B, the pattern given is like this. It's given as Z, right? So how many can you see here? How many sticks can you see? 1, 2, 3. We see 3 matchsticks. So 3, all right? And depending on how many Z's you make, this n will be substituted, okay? So if you are making 1, 2, 3, if you're making 3 Z's, in place of n, you will write 3 into 3. So total you used 9 matchsticks. All right. So this is the idea behind the representation using a variable, all right, with matchstick pattern. Let's look at question E. In E, you see, this is question number 1. E, you see E again. So I'm using 1, 2, 3, 4, 5. I'm using 5 matchsticks here. 1, 2, 3, 4, 5. So 5 I will write as the number, and for the number of E's I will use n. Okay, so even if you draw 100 E's, okay, if you draw 100 E's, you simply substitute n by 100. That means 5 into 100, it will give you 500. That means to draw 500 E's, you are using 500 matchsticks. All right. So this is the basic concept about the question given. Now let's move to question number 4. If there are 50 mangoes in a box, there are 50 mangoes. Okay. How will you write the total number of mangoes in terms of number of boxes? So for one box, in one box, there are 50 mangoes. So if I want 4 boxes, such boxes, how do I represent this, right? How do I represent the total number of mangoes in terms of number of boxes? Okay, so first we'll write down like this. Let's use A, okay? Let's use box, so B. Let B be the number of boxes, right? So the number of boxes is denoted by B. We don't know how many boxes, but if you use 5, this B will be equal to 5. If you use 4 boxes, B will be equal to 4, all right? So let B be the number of boxes and number of mangoes in a box. It is already given as 50, right? So therefore, total number of mangoes. They are asking us the total number of mangoes in B boxes. That means we don't know how many boxes there are. We are simply representing by B. It can be 5, 6, 7, 8, all right? So this will be represented like this. Total number of mangoes is 50. And the number of boxes given is B. Okay? For example, if you use only 2 boxes, you have 50, 50, 100. So if you use this expression, 50, and in place of B, I will put 2. 1, 2, right? 2. When you multiply, you get 100. Right? So that is how you find the number of mangoes in 2 boxes. If it is 3, you substitute here 3. If it is 4, in place of 2, you put 4 and multiply. All right? You get 200. All right? So this is how you use the expression. Let's move on to question number 5. Question 5. The teacher distributes 5 pencils per student. Per student, one student gets 5 pencils. Can you tell how many pencils are needed given the number of students? So they have given us a hint. Use S for the number of students. So question number 5. Let S be the number of students. All right. S is the number of students and number of pencils given per student. So each student received 5 pencils. So we can say total number of pencils given to S students is one student receives 5 pencils and this is the number of students. 5S simply means 5 into S, okay? So if there are, let's say, if there are 10 students, so the total pencil that you are using is 5 into, in place of S, I put 10, 50. So total number of pencils required for 10 students is 50. Okay, children? So this is all about question 5. Let's move on to question, okay. Let's move on to question 8. Leela is Radha's younger sister. Leela is Radha's younger sister. Leela is 4 years younger than Radha. Can you write Leela's age in terms of Radha's age? Take Radha's age to be X years. Since Radha's age is not given, we will write let Radha's age be X because Radha's age is not given. But they are asking us to write Leela's age in terms of Radha's age. Okay, so in terms of X. So Leela's age is equal to, she is 4 years younger than Radha. Right? In the question, it's given that Leela is 4 years younger than Radha. That means Leela is 4 years Leela's age is 4 years less than Radha. So what do we have to do? We can write like this. Leela's age is equal to 4 years less than Radha. How old is Radha? Radha is X years old. Now to find Leela's age, we have to minus 4. Okay, that means Leela is 4 years younger than Radha. Okay, so this is the answer for question number 8. Let's move to question number 10. Oranges are to be transferred from large boxes to small boxes. We are going to transfer oranges from big to small box. When a large box is emptied, the oranges from it fill 2 boxes. Okay? If you take out the orange from here, it fills up these 2 boxes and still 10 pieces remains outside. If the number of oranges in a small box are taken to be X, what is the number of oranges in the larger box? So number of oranges here is X, X, okay? So let's write. They have already given us a hint. Number of oranges in smaller boxes is equal to how much? We will take it as X. It's already given in the question. So we will write number of oranges in 2. There are 2 smaller boxes. So for 2 smaller boxes, number of oranges become 2 times X. 2 times, right? So I will write 2 times X. Okay? Now, number of oranges that remains. Number of oranges that remained outside, right? We'll just write remained is equal to 10. So to find the total number of oranges that can go here, add this plus this. Okay? So what do we have? Number of oranges in larger box is equal to the number of oranges here plus the 10. Okay? So that means number of oranges in 2 smaller boxes. In 2 smaller boxes is 2x. And the number that is outside plus. So if you combine these, it gives you the total of oranges in here, isn't it? Because it came out from here only, right? So 2x plus 10 represents the total number of oranges in the larger box. All right, children? So that is all for question 10. In this exercise, we will be doing only this much. We will move on to exercise 11.2. 11.2, it's quite easy. This is 11.2 now. Exercise 11.2, question number 1. It reads, the side of an equilateral triangle is shown by 1. We have already learned equilateral triangle. Equilateral triangle means all the sides are equal. And one side is given as 1. Express the perimeter of the triangle, equilateral triangle using 1. Look here, one side is 1 means all the other sides are 1 because in equilateral triangle, all the sides are equal, okay? I'm so sorry, it's not 1, it's L. So if one side is L, 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 we don't know how much it is, all right? So they're asking us to express it in L, using L. So we can write side of equilateral triangle. It is given as L, right? It is given as L, one side. Now, we also know that perimeter. We have studied this. Perimeter. Perimeter simply means addition of all the sides, right? So, L plus L plus L. So, how many L's do we have here? We have 1, 2, 3. So, we will write 3 and then take 1 L. The same as L plus L plus L, 3L. Okay? 3 times L is same as L plus L plus L. All right, children? So this is how you express the perimeter using L. Let's look at question 2. The side of a regular hexagon. Hexagon is a shape that has how many sides? 6 sides. Hexa 6. Okay, and it is denoted by L. Express the perimeter of the hexagon using L. So same thing again. 1, 2, 3, 4, 5, 6. All right. So L, 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 L. A regular hexagon. When you say a regular hexagon, if one side is given as L, all the others are also L, because a regular hexagon has all the sides equal. Okay. So again, to find the perimeter, simply add all the L's. Start from here. L plus L plus L plus this L plus 2 more L. So we have how many L's? 6L. All right. So this is how you represent your perimeter of a hexagon using the letter L as and this L acts as your variable, because if this length is 2, your L will be equal to 2. That means all of this will become 2, right? So to get the perimeter, 6 into, in place of L, I will write 2. 6 into 2 is 12, okay? So this is how, if it is 3, if the length is 3, it will become 3 and it will become 18, right? So if it is 4, here we will write 4 and it will become a different number again. So according to the length of the side of the hexagon, the answer will vary. All right. With this, we come to the end of the exercises 11.1 and 11.2. We will continue with the other other exercises in the next class. So please practice all of this. If you have any doubts, please try to go back to the last video where we discussed about the concepts. So until we meet again, please take care and study hard.